On January 2017, Tradelossa performed the installation of different steam turbine components and a steam generator for the combined cycle power plant Empalme 1 at Sonora, located in the northwestern desert of Mexico. Sector: Power Generation. The steam turbine was divided into 3 sections. The top part was 20.6 feet long, 10.46 feet wide, and 10.89 feet tall, weighing 264,000 pounds. The mid part was 18.47 feet long, 12.36 feet wide, and 13.15 feet tall, weighing 282,000 pounds. The third part was the outer casing of the turbine, which was 29.85 feet long, 26.24 feet wide, and 12.79 feet tall, weighing 198,416 pounds. The additional component was the steam generator, 37.72 feet long, 16.07 feet wide, and 15.74 feet tall, weighing 672,410 pounds. Physical elements. The combined cycle power plant Empalme 1 is located in the municipality of Empalme in the state of Sonora in northwestern Mexico. This is a project that, when finished, will generate 770 megawatts to supply an important part of the energy demand for northern Mexico. The scope of work included the installation of an outer casing, 2 steam turbines, and 1 steam generator. Traditionally, these type of components are installed before the building complex is constructed, taking advantage of the open space to execute the rigging task. In this case, the building surrounding the installation site was mostly set up, adding complexity to the challenge from the start. Due to the customer's tight schedule for this project, Tradelossa made a thorough analysis of the challenges that had to be considered. The foundations were 49 feet above ground level, and with very limited space to work around them, precise calculations were required to execute the rigging operations. To lift and install the components, our engineering department decided to take advantage of the reduced empty spaces left in the foundation, where they had to adapt not only the steam components, but the equipment to lift them. As if the challenge of installing the steam components weren't difficult enough, the building and the rest of the power plant was being constructed at the same time. This made the process even harder, not just because the steam components were critical for the process, but also because of the risk of the construction itself, on top of the extreme desert weather conditions. Critical points were previously analyzed to execute the plan that needed precise calculations to guarantee full safety measures and our customers' satisfaction. Main challenges: entering the building in a narrow space, access of only 22 feet in width. Extreme weather conditions. The exhausting heat of the desert, with temperatures above 100 degrees Fahrenheit, and the constant rainy days were another factor that made the rigging more challenging. The challenging installation plan, 49 feet above the ground. The use of different rigging systems at the same time. Setting up the gantry system on repetitive events in a very reduced area to perform different rigging moves. Placing the strand jack and jack and slide system in a very narrow space, 49 feet above the ground. The building complex where the rigging was executed was being constructed during the entire process. Our customer demanded best quality on their processes, so in this particular case, all Tradelossa staff who worked on the project had to comply with a detailed certification process. Safety considerations. Self-done ground and field analysis, safety training, experienced staff, expert operators, supervisors, and a large support team, 1 gantry system, jack and slide system, strand jack system, supporting stacks, steel mats, a 14-axle hydraulic equipment, and lashing equipment. Constant coordination with all Tradelossa's team involved in the project. Permitting. Use of the adequate safety equipment. Weather forecast to adapt working times to the reality of weather conditions, and adequate hydration levels of the staff. Planning the job. From September to December of 2016, 840 hours were dedicated by the personnel to provide a plan adjusted to the special needs of the project. The plan was made 4 months before the rigging was executed because of the limited alternatives left to install the steam components in the machinery room. The easiest solution would have been removing part of the ceiling from the machine room and using a crane to lift and install the 4 steam components from the top of the roof. But the client didn't want to delay nor rebuild the construction schedule. Tradelossa's personnel expertise found a suitable solution to comply with all of our customers' needs. The best solution was to first strategically set the components at critical locations inside the machinery room, starting with the top turbine, then the steam generator, followed by the outer casing and mid-turbine. This was not the order in which the rigging sequence would normally be done, but having the components on set allowed us to gain some extra space to enter with the gantry system and the rest of the rigging equipment in order to execute the rigging job in a more complex sequence, leaving no room for mistakes, but making it more time efficient. Permits. Several permits had to be issued before and during the project. Before the project began, Tradelossa's site team had to submit a security procedure that satisfied the very demanding safety measures requested by our customer. Equipment configuration. To perform all of the rigging operations, a 550-ton gantry system, 2 stand jack systems, each one of 300-ton capacity, jack and slide system, 1 overhead crane, and supporting tower stacks were used. A 14-axle hydraulic trailer was used to transport the components inside the room. For the unloading operations, assembly, testing, and approval of the gantry system with the overhead crane. Transportation of the components in a 14-axle hydraulic configuration to place them inside the machinery room. Unloading operations of all the components with the gantry system over the jack and slide system. Sliding operations of the components and placing them in their design locations with the jack and slide system. And dismantling of the gantry system to free up space. Tradelossa's engineering team had to decide the setup sequence of the components, since this was the key part of the plan where we had to reduce the schedule. The simpler option was to first enter the outer casing turbine, followed by the generator, then the top turbine, and ending with the mid-turbine. But this option was not feasible due to physical constraints. By following this procedure, the HP and IP turbine would have had trouble to fit the outer casing once they were all installed. This would have caused the reworking of the entire process and the loss of valuable time. The alignment of the components was the most critical factor for their optimal performance once positioned. Tradelossa's team thought of a different sequence that involved starting with the top turbine, then with the generator, followed by the outer casing, and finally with the mid-turbine. Lift and installation process. Assembly, revision, and approval of the gantry and strand jack system over the supporting stacks. Sliding operations of the pieces with the jack and slide system to place them in a suitable position. The lifting procedure was another task we had to analyze before starting the work. Once the steam components were grounded, we had to relocate the gantry system to leave space to access the 2 tower stacks that would support the gantry system 49 feet above the ground. An additional critical point was the narrow space available to lift and slide the components and install them inside the platform. Execution: 1,850 man-hours, 11 operators, 12 working hours a day. With a prior analysis to perform an error-free rigging job, we were ready to begin. Loading, unloading, and positioning procedure. All the equipment, including the gantry and the jack and slide system, were set up in an extremely reduced space while ensuring no damages to the construction or the components. The gantry system was set up with an overhead crane in a narrow space next to the platform where the components were going to be installed. The overhead crane helped us install the power units in a safe and precise process. The first component to load was the top turbine, for which we used a double 14-axle hydraulic configuration. Once the turbine was over the trailer, the equipment had to move backwards in a very narrow entrance. One of the main challenges was the constant construction of the power plant. The roads where we had to operate were obstructed by the construction material or were in poor condition. We had to look for alternate roads, making the transportation more challenging. Once we found a good option, we came in with the first component, the top turbine. The HP turbine was placed with two systems. First, we lifted it from the Goldhofer equipment with the gantry system. Then the jack and slide was used to locate the component next to the platform. The steam generator was next and followed the same process. The generator was lifted and located with the gantry system and slid to the other side of the platform. Once this was done, our team positioned the outer casing with a double configuration of 14-axle hydraulic trailers, leaving the component in front of the platform, and then placed it over the jack and slide with the gantry. The last component to be installed was the IP turbine. For this component, our team used a 14-axle hydraulic configuration that located the piece in front of the outer casing. Rigging job. Having all the components positioned as per the engineering plan, the gantry system was relocated to allow additional space to the tower stacks installation. The space was critical. The building was full of components that left us no margin for error. The overhead crane helped our team to do the installation of these stacks at the corners of the room. Once the gantry system was relocated in the platform 49 feet above the ground, the strand jack system was installed above the outer case turbine. This would be the first component to be lifted. Once both systems were set up, the lifting process began. Inch by inch during the 49-foot journey, the installation was monitored at all times. Then our team started lifting the outer casing, following the agreed-upon procedure. Once in the air, the platform under the casing was prepared to anchor the piece to it, and the casing was slowly lowered to its right position. With the outer casing well positioned, we had no trouble aligning the rest of the turbine. The next component to be lifted was the HP turbine, but in this case, the turbine had to be first slid at ground level, since it was aside the platform. Once the turbine was slid with the jack and slide system, the strand jack lifted it and installed with the same procedure as the outer casing. This time, the piece passed over the casing. After this, the strand jack was slid to the IP turbine position, repeating the HP process. The final lifting was the installation process of the steam generator. For this procedure, the engineering team thought of using two strand jack systems to lift and install it, since the weight of the component was heavier than the turbine components. Once the two-strand jack system was installed, the generator was ready to be lifted and installed. No incidents occurred and no time delays were experienced accomplishing the committed plan. Key factors. This project had many obstacles to overcome, starting with the time required for the complete installation, the reduced space our team had to deal with to handle the components inside the building, and especially the height of the platform where the rigging job had to be performed. Although the installation sequence wasn't common, this rigging challenge proved that preparation, innovation, teamwork, and discipline could deliver the same successful outcome that a traditional installation could achieve. The key factor that allowed us to overcome this arduous challenge was our team's broad experience, creativity, and determination to accomplish the goals set by our customer to deliver top-quality performance, making this operation a complete success. Conclusions. Total man-hours, 2,690. Planning hours, 840. Execution hours, 1,850. Equipment used, a 550-ton gantry system, a jack and slide system, a 300-ton strand jack system, a double configuration 14-axle hydraulic trailer, supporting tower stacks, and an overhead crane. Total handling operations, 14 operations. Total distance traveled, 49 feet above the ground, followed by a 92-foot sliding operation. Formula to succeed: world-class customer, world-class safety standards, world-class team. Dare for new solutions.